In the sprawling, chaotic landscape of the internet, there are few places as notorious as 4chan. It's a corner of the web, known for its unfiltered memes, its controversial communities, and its profound influence on internet culture. It is not, by any stretch of the imagination, a place you would expect to find a breakthrough in academic mathematics. But in 2011, on the Science and Math board, something extraordinary happened. A user, completely anonymous, posted a comment that would go on to solve a piece of a mathematical puzzle that had stumped experts for decades. The post wasn't a formal thesis or a carefully structured paper. It was a casual reply to a question about the most efficient way to watch a Japanese anime series. This is the story of the Haruhi Problem, a quirky thought experiment that accidentally collided with a serious field of mathematics called combinatorics. It's a story about how a discussion over a cult classic anime, The Melancholy of Haruhi Suzumiya, led to a genuine mathematical discovery, with an anonymous 4chan poster now credited as a co-author on a formal academic paper. Welcome back to Vanishing Threads. Today, we're exploring the improbable true story of the 4chan mathematics proof. We'll unpack the surprisingly complex problem at its heart, trace the journey from an anime forum to the halls of academia, and ask a critical question. In an age where expertise is often gatekept, what does it mean when a profound discovery emerges from the most unlikely of places? And how does the anonymity of the internet both enable and complicate the recognition of genius? To understand the proof, we first need to understand the problem. And it all begins with a question that plagued anime fans for years. What is the correct order to watch The Melancholy of Haruhi Suzumiya? The anime, first aired in 2006, is a story about a high school girl, Haruhi, who possesses unconscious godlike powers to alter reality. She's bored with the normal world and seeks out the supernatural, dragging her cynical classmate Kion along for the ride. The show's production studio, Kyoto Animation, made a daring creative choice. They broadcast the first season's 14 episodes out of chronological order. The finale of the story arc was aired as the first episode, while the true beginning was shown sixth. This non-linear structure created a sense of mystery and disorientation that mirrored the protagonist Kion's own confusion, forcing the audience to piece together the timeline themselves. When the series was released on DVD, the episodes were rearranged into their chronological sequence, offering a more straightforward narrative. This immediately sparked one of modern anime fandom's great debates. Do you watch it in the broadcast order, preserving the artistic intent and initial mystery? Or do you watch it chronologically, for a story that makes more conventional sense? This wasn't just a casual preference, it became a core part of the show's identity and fan culture. In September 2011, a user on 4chan's sideboard took this debate to its logical and absurd extreme. They posed what would become known as the Haruhi Problem. What is the shortest possible marathon of episodes required to watch every single possible viewing order of the 14 episodes? This wasn't about just 2 orders, it was about all of them, every permutation. This question, likely intended as a nerdy thought experiment, was unwittingly a restatement of a well-known problem in the mathematical field of combinatorics: the search for the shortest superpermutation. A permutation is just an arrangement of items. With 3 cards, there are 6 ways to order them. A superpermutation is a sequence that contains every possible arrangement hidden inside it. The challenge is finding the shortest one possible. Mathematicians had noticed a pattern in the lengths, but couldn't prove it always worked. The Haruhi Problem, with its 14 episodes, was asking for the shortest superpermutation of 14 items. The number of possible ways to order 14 episodes is astronomically vast, more than 87 billion different arrangements. A computer trying to check every possibility would take forever. This was a problem of immense scale. Less than an hour after the Haruhi Problem was posted, a 4chan user replied with an elegant proof. They established what mathematicians call a lower bound, essentially proving that no matter how clever you are, the answer can't be smaller than a certain number. It was a significant constraint that no one had found before. This was a major step forward. The previous best guess at the minimum was much looser. This new proof was tighter, narrowing down where the real answer could be hiding. The approach was clever, treating the problem like finding the shortest route through a network, which revealed constraints no one had spotted before. The author ended with, "Please look over the proof for any loopholes I might have missed." For 7 years, this significant mathematical work sat hidden in a 4chan archive. The work remained unnoticed until 2018, when science fiction author Greg Egan sparked renewed interest in superpermutations. Egan is renowned for his hard sci-fi novels, which are deeply rooted in rigorous scientific and mathematical principles. He doesn't just use science as a backdrop, he explores its philosophical and human implications. In October 2018, Egan posted on his website that he had found a new upper bound for the superpermutation problem. An upper bound is a ceiling, a method that is proven to generate a valid superpermutation even if it's not the absolute shortest possible one. Egan's method produced superpermutations that were shorter than those from the long-standing factorial conjecture, effectively proving that the old wisdom was wrong for n greater than 5. This was a bombshell in the niche community that followed the problem. Egan's discovery was shared on Twitter, where it caught the eye of Robin Houston, a mathematician at the University of Cambridge. Intrigued, Houston began looking through the comments on a Google+ post discussing Egan's work. There, he saw a link to the old 4chan thread. The link was accompanied by a comment suggesting that an anonymous user had years earlier established a new, lower bound. Houston, curious, clicked the link. What he found was the 2011 post. It was messy, written in 4chan's casual vernacular and filled with informal logical leaps. But the core argument seemed sound. Houston decided to formalize it, translating the rough sketch into rigorous mathematical language. Independently, Jay Pantone of Marquette University had begun the same process. For weeks, they worked in parallel, reconstructing the logic and verifying each step. Both reached the same conclusion. The proof was correct and significant. When they finally connected, they realized they had both validated the same contribution, a major advance that had sat unnoticed for 7 years. When it came time to publish the findings, Houston, Pantone, and another colleague, Vince Vater, faced a unique ethical dilemma. The author of the lower bound proof was the intellectual originator of the work, but they were completely unknown. To publish without crediting them would be appropriation. Their solution was as unconventional as the story itself. They listed the first author of the paper as anonymous 4chan poster. This act was a powerful statement. It formally acknowledged the intellectual contribution of the anonymous user, cementing their place in the history of mathematics. The paper, titled "A Lower Bound on the Length of the Shortest Superpermutation," was published on the academic preprint server archive, and the story quickly went viral. It was a perfect internet tale, a collision of high-level mathematics, anime fandom, and the strange anonymous culture of 4chan. The story of the 4chan mathematics proof is more than just a quirky anecdote. It's a powerful case study in the changing nature of knowledge and discovery in the digital age. For centuries, scientific and mathematical breakthroughs were the domain of established institutions, universities, research labs, and academic journals. Expertise was cultivated, vetted, and recognized through formal channels. This structure, for all its flaws, provided a clear pathway for ideas to be tested, published, and archived. The internet has democratized knowledge creation in unprecedented ways. The 4chan proof shows that insight can emerge from anywhere, unbound by credentials. Anonymity, often associated with chaos, can also create space for pure contribution, where ideas are judged on merit alone. Consider Satoshi Nakamoto's Bitcoin or citizen scientists solving protein folding problems through games like Fold It. Yet this story also reveals the challenges. Without formal academic structures, significant work can languish unnoticed. It took chance encounters, a science fiction author's blog post, a shared link, to bridge the gap between internet forums and academic recognition. The identity of the anonymous 4chan poster remains unknown. They have never come forward to claim credit. Perhaps they're unaware of their impact, or perhaps they understand that the beauty of their contribution lies in its anonymity, a gift to the world of mathematics. The 4chan proof began with a playful question about an anime series and ended with new mathematical truth. It reminds us that the next breakthrough might not come from a prestigious university, but from a stranger in a forgotten corner of the internet, driven by nothing more than curiosity. Thanks for tuning in, and until next time, stay curious, stay safe.